Alright, so I hope you guys are all done with the class activity. So let's just go over it, and yeah, we'll start from here. So alright, so um, this is the plot, and we went over how to filter the information. You just click on the header, right? Drag it, and then you go to data, and you just click filter, and you'll have all this click button here. So what we want to do for male is just select male only, right? And then you have all these information. So you're going to copy down current salary and current education, right? You copy this down, and then you move it on to another tab here. Okay? So that's what I did, but I just switched X and Y because it's um, actually it doesn't really matter if you change it or not, but I just would like to have the years of education as my X value, because that's more like a conventional way of doing it, because that's on the X-axis, and you want to have the result, quote unquote result, on Y-axis. So I had that X and Y, and X meaning the years of education, and Y is the salary. So I just copy this down from the previous um, filter table, right? And to look for the correlation coefficient, we're going to do it manually first, and then we're going to do the built-in functions. We're not going to use the manual calculation of correlation coefficient or anything like variance or standard deviation, but we're just doing it for the first time, so that's why I'm trying to reinforce the equation in your mind. All right, so let's do that. So first of all, we look for x bar, which is the mean, sample mean. So if you go all the way down, I did it here, average. Okay, before I forget, let me just zoom in. Okay, so this is a little better. Let's go all the way down. So this is the average, and if you look at the formula, it's always the same. I did average, and then I gave it a range, and I did the same thing here. And standard deviation, we use stdev.s because this is a sample, and then I gave it a range. Same thing here. I did that, and I counted the number of observations by doing countif greater than 0. Right? So enter, and I have these values. Alright, so if we go up again, here is what we do is we sum up all the values. Xi, which is ith observation, minus x bar over standard deviation of x. So here, if you look at the formula here, I did xi minus x bar, I locked the value, right? And then divide it by the sample deviation, and I also locked the value there. So if you copy that down for all values, this is what you get. And I did the same for y. yi minus y bar divided by standard deviation of y. And it's referring to the cell below. So whenever you change the number, if you change one observation, it's gonna change as well. It's automatic, so you don't have to worry about that. And this is like a building a model, right? So that's that, and then we multiply E column and D column and E column, right? This is what we get. And then if you go down, I summed it up. This, I forgot to label this, right? So this is a sum of all products, and that's what we're looking for, because we are looking for the sigma of all products. So this is the sum, and what we do here is we divide this number by n minus 1. So divide this number by n here minus 1, and that's what you get. Alright, so if you do the same for coefficient, if you use the coefficient correlation function, correl, right? Give it a range and another range, because we're looking for two variables, x and y. If you do that, you get the same value. So great, it worked out. And now we're plotting the salary versus years of education for male, right? So to do that, you just click these values and you press scatter plot button. And I want to show you something here. So if you click this, you get a plus sign, little plus sign here, right? So if you click that, they give you an option. Axis title, chart title, data label, error bars, grid lines, and everything. But we want to see the trend line, right? Trend line. To say the list, to put it into a simple terms, is a line that minimizes the value, the difference between the line and the observation, right? So we're going to build up a line where it's best fit. So if we minimize the value to observation differences, okay, and this is a line that we get. It's kind of slanted, right? Um, yes, it is kind of slanted, and if we see that from the graph and from the correlation coefficient, which was, I forget what it was, 0.6 something, I believe. All right, so R was 0.645. All right, so it's not that strong, but there is a rough weak positive linear relationship going on here, right? So that's what we see there. Um, and there is a weak positive correlation and linear, right, which means there is a weak linear um, relationship between the two. And if you do the same for salary of um, female, you get a similar result. I did exactly the same, but here we get R equals 0.5356. Or let me just make sure this is the right answer by using correlation function. Alright, so this is alright, so I messed it up. Let me do this again. Okay, so that is the first array. And the second array we have is the salary. And we get the same number. Right? So if it's um, 0.5 above 0.5, oops, this should be if it's above 0.5, there is a weak positive linear relationship, right? But this value is less than the one before, right? Male versus for male, because for male it was like 0.6, and there is a weaker relationship. So if you look at the plot line here, it's slightly increasing, and if you put the trend line here, okay, trend line, let's click on that, plus, and then trend line, you see slightly slanted, so that's a positive, right? It's not going down, it's going up, but it's very weak, so it's not that strong. Right? So comparing these two values, right, we can infer that there is a stronger correlation for male than female. And if you think about the reason, there is we can infer from this data that there might be a discrimination, right? So if male have higher correlation, that means that they generally tend to have a better or more slanted line here, right? For years of education and salary, whereas for female it's a little weaker. But it's not to say being a man gives you better salary if you have a higher number of education. That we never say that. And that's what we're going to discuss next. Okay, let's go back to our note. Okay, so this is okay, so we call that correlation causation. So what we say here is that even if there is a high correlation, say if you have a perfect correlation, R equals 1, right? So even if there is a high correlation, okay, it doesn't mean that there is a cause and effect relationship, okay? This doesn't necessarily mean that there is a cause and effect correlation, effect relationship. So this does not mean that there is a cause and effect. So let's look at a classic example. This is one of the classic example to disapprove of what we just said before, right? Um, for in European countries, there are these kinds of birds called stork. I'm not really sure what these are, but these are types of bird, right? And they have high number. In there is a big population in Europe with these kinds of birds, and there is also a high correlation between this and number of strokes. Okay, strokes meaning um, the disease, right? When the blood vessels get clogged up and you get you kind of pass out, and it's a really deadly disease. Um, Not disease, but it's more like a medical condition from high pressure or sometimes diabetes as well. So these are highly correlated. So high correlation between these two. So meaning high correlation coefficient, right? But does that mean having many number of torques, does that cause more strokes? No, these are not related at all. I mean, there might be a, a relationship between the two, but this doesn't necessarily affect the number of strokes. In fact, if this was the case, if you kill all these birds, right, then you would have less stroke and you would have a lower death rate. But that doesn't make sense at all, right? Because this is not directly causing the strokes. It's just a relationship between the two, that there is a, a linear relationship. So it doesn't, one doesn't necessarily mean that there is a cause and effect relationship. It just means that there is a relationship, a linear relationship, but it doesn't necessarily cause one or the other, right? And now I would like to discuss something called lurking variable. And we discussed this briefly before, and this is when um, there is a third variable present that are not um, in fact that is not, sorry, there is not factored into the analysis. Okay, so what it means is that when we're looking at two variables, we are only consider when we are doing the correlation coefficient, we're only looking at two variables, right? But there might be a third variable that's affecting the data. Okay, but this happens, the lurking variable happens when we do not factor into account what's going on. All right? So, um, so going back to our class activity, let me just, no, this is not. All right, so um, this is the activity that we went over, right? So if you look at this, um, although we just assume that these minority classification does not affect the salary, but it might, right? We don't know how to do this yet because this is a categorical data, and we're gonna I'm not sure if you will have time to discuss this, but this is something called chi-squared, where we also factor into account the categorical value, right? And we're going to see the relationship between the categories and different categories and the result. So if you do the minority classification with the salary, there might be a relationship between the two instead of the years of education. Right? So these are all the factors that might affect the results of these two relationships, and we kind of factored into account the gender part because we divided up into two different categories, right? We have male and female separately. That's how you factor into account these variables, right? So if you look at male, only male, right, we see a stronger correlation coefficient, whereas female has a little lower correlation coefficient. So these we call the lurking variable, anything that is affecting that might be affecting the data or the relationship that we are looking at, right? So that's called the lurking variable, right? So it's always important to comment on this because in statistics you're never gonna find a perfect model. Like it's impossible to see anything that perfectly fits the model. And this is what statistic is for. We're just guessing. We're making estimates. And when we are making a report or when we are analyzing a data, we have to comment on these variables. And even for really advanced statistical reports, they always make assumptions because it's never possible to have uh, um, to meet these assumptions. So we make certain assumptions, but we have to make comments. So for reports like this, when we're looking for relationships, you have to make sure you mention all the variables that might be all affecting, or not all of them. You don't have to list all of them, but the major ones. So for example, for this one, for the class activity that we just did, right? You even after you mention the um, correlation coefficient for salary of male and female, you might want to mention um, the existence of minority classification. So although there is a weak positive correlation between the years of education and current salary, um, there might also be other variables, other lurking variables that might be affecting the data and the result. And those are minority classification and also the gender, although we factor into account, right? We have to mention that. And that's more important than the numbers that we're giving in. We have to make sure we cover all the variables that are not covered in our report. And also later on, we're going to mention something about errors. And it's really important that we mention errors because what if, say, we are looking at an election poll, right? And statistics is very iffy when it comes to those political schemes because why? Because we sometimes they want to manipulate us, and sometimes it's biased. Sometimes it's leading to one way, whereas the other poles are different, right? So you have to make sure you have to be neutral as possible. So you want to make sure that the error is as low as possible. And when we're looking at the statistical report, you have to make sure that you cover all those topics and errors as well, although we didn't cover that yet. All right, so that's it for today. I just want to go over something up from the homework. So this is the homework that I assigned for today. Let's make it a little bigger. Okay, so it's the same thing. The following table shows the number of cell phone subscribers, number of person in prison, and the number of registered motorcycles. Right. So we're just looking at the so here this is the US data, but in US if you're using when you're driving, you get fined and sometimes you go to jail. So that's what it means. And these are the number of people in jail in millions. So this is 1.2 million, and these numbers are cell phone subscribers. So people with cell phones pretty much, and you have more motorcycles registered, right? And these are all in millions, and you don't have to really worry about the units because these are all in same units. And you're supposed to create a scatter plot and identify the kind of association using correlation coefficient, right? So here, um, what we're looking at is the number of inmates, number of people in jail. And we want to see if there is a relationship between this and cell phone subscribers and this and register motorcycles, right? So you have to do two separate analysis and make sure you separate them. So that's for part A, and then you have to comment on possible lurking variables, right? So anything that's not listed here, you might be wondering, oh, is there anything else that might be affecting the number of inmates, right? So that you have to think. So question number 2 is similar. We have garbage and population, and you have to plot the garbage versus year. And oh, I forgot. Garbage versus year and garbage versus population. So I want you to do the two-way thing again. So year versus garbage and year versus no garbage versus population, and if there is any relationship, and find the correlation coefficient to back up your statement. Okay? And you have to also comment on the lurking variable here. And this is the biggest file, and this is pretty interesting. So these are the athletes who have won any medal in the Olympics. Okay, and we have athlete name, so Michael Phelps, and we have age, country, sport, and then we have gold medals, silver and bronze medal, and number of total medals. Okay, but this is how we're going to see this for each gold medal. We're going to make a scoring column here, and we're going to see if there is any relationship between scoring and age. Okay, so so how the scoring works is the following. So for a gold medal, you get 3 points, right? Silver, 2 points. Bronze, 1 point. And I want you to create a column here in the I section for the scoring. So for Michael Phelps, when he was 23, he received 24 points because he received 3 gold medals, right? And I want you to create an equation or a function listing all that, and I just want you to like copy and paste because that's the easiest way to go. You're not going to spend all day calculating this, so please do that, and then describe any linear relationship, right? And you're going to first you're going to do this manually and compare the result with the built-in function, and you have to comment on the lurking variable. Okay, and for this we're looking at swimming, and also I forgot what it was, and archery. Okay, so you have to use the filter section, and then you would do the same thing as we did for the classwork. Okay, so that's your homework. So please work on them, and if you have any questions, please make a comment so we can go over those questions during Q&A session. Alright, so best of luck, and I'll see you tomorrow.